So I'm Hazel. I'm Head of Sales and Marketing at EA Technology for the asset management side of the business.
Hi everyone, I'm Gareth Devine. I head up the UltraTEV side of the business, which is the partial discharge side. And I've got 16 years experience in PD measurement and instrument design, so they align to today's topics.
Perfect. So we'll just move into the presentation. So just a little bit of background into EA Technology. Our heritage does go back to the 60s where we began our PD research. We've got a really long history of understanding the technology and how best to measure it and what we should do with that data in terms of managing assets going forward. We are now global leaders in PD technology, as well as global leaders in network and investment modelling and monitoring across both HV and LV. We do have a global presence with regional offices in the United States, Australia, Singapore and China as well. So what is it that we do as a business? Our products and services really are designed to help owners and operators of power networks keep the power on, basically. We aim to create safer, smarter, stronger networks. And we produce the equipment that will allow networks to be managed cost effectively and prevent catastrophic failures and the subsequent financial losses. EA Technology offers complete support all the way from design through operations and maintenance, and also future planning of networks. And today's focus is on the preventative maintenance. So how does PD testing reduce risk? Risk, I'm sure you all know, is made up of lots of different factors. And PD monitoring, condition monitoring helps to reduce risk and therefore enables the probability of failure to be reduced by ensuring customers have the data to inform maintenance strategies going forward. We will be doing a series of webinars which will be looking at different areas of PD and how it can be used going forward over the next couple of months.
Thank you. So today's presentation is very much it's quite wide ranging. We're going to start with some basic PD theory and it's very much an overview. We will, and I'll point them out as we go through, be doing follow-up webinars in more detail in each section over the next few months. But hopefully today I'll give you a flavour of what is PD, why it's important to us, some examples of what people have found on their sites over the last 12 months, and some of the benefits of that and their findings. What's changed? So PD's been around a while, the attitudes to it have changed, the usability of the equipment has changed, and the value of the data we're collecting and follow-up actions has increased. So what the feel for what's changed around that, and where you could take your PD data next. So I'd say it's a fairly broad range. We'll have some questions related to these areas that come through. I'll answer them as we go through, but certainly there'll be follow-up lectures in more detail as well. So starting at the very top, what is PD? And it's always good to have a standard to lean on. So IEC 60270 defines PD as the partial bridge of insulation. So this is an arc, a breakdown of the insulation over a small part of the insulation. It isn't an arc from conductor to conductor or from ground to earth, so from live to earth. This is just a breakdown across a very small part of that insulation. It'll be a small spark, it's electrical stress around the area, and it'll slowly eat away at the insulation around there. So once it starts, it'll continue to deteriorate. It can happen anywhere in the insulation system, so that's in the cables, the terminations themselves, and or cable joints, or within some of the spouts, the surface of the equipment, or even any other fixed parts of the bus bars, etc. So anywhere in the HV insulation system where there's stress. So what's that actually mean? So take a look at it in a bit more detail. Let's start with the more interesting side of the slide on the right hand side, the pictures there. Top picture with that lovely blue colour at the base is actually a spout off a live network. You can see on to the left-hand side of that picture and to the back some carbonisation. The carbonisation there is tracking, it's surface tracking, that surface breakdown of the insulation, where these little sparks, this little PD activity, have started to eat away and shorten that conductive path, basically, so leading you towards a flashover. Just a reminder, that's come off a live piece of equipment. As is the next, this is the picture just slightly below is an internal void, and you can see there how the insulation is meant to be consistent all the way through, and has now got these big air voids inside where it started to break away and eat away at the insulation. And the final picture is an old favourite. So phasing tape has been left on the cable termination, and that over time has started to cause an area of high stress and eat away at the cables, leading to failure, or potential failure in this case. So I mentioned that high stress, and that this is the root cause of PD, really. So in an ideal world, the insulation will be consistent all the way through, and the stress level will be equally divided across that. So when you look at cable termination kits and jointing kits, there's materials in there to manage the change of stress. You fill any voids are filled with mastics, etc., and it's to avoid any build up of that stress, the electrical stress, across a small area. So the diagram on the top left is what happens when you have an imperfection in there. So we look at the air void in the right hand side, for instance. That would allow the pressure, the electrical stress, to build up and concentrate around that point. So rather than the electrical stress being spread evenly across insulation, it is very much focused around a small area. That will break down, you'll have a small spark, release of energy. That does some damage, as you can imagine, and then the whole process repeats. And that's why once you have PD, unless you address the root cause, it is going to continue. It will continue to move towards failure. And that's again, what we're trying to avoid. This is all about keeping people safe and keeping the lights on. Might start to wonder whereabouts in the switchgear this might occur. That's the kind of case in the bottom left-hand gear, left-hand side there. And it's certainly a fact of life that we cause a lot of these issues. So when we're in there doing maintenance, when anywhere that we've done installation on site, cable terminations or moving parts, they're the parts at higher risk. But they're not the only parts. There are common failure modes in different types of switchgear, design flaws, or even just impurities in the air, humidity, etc., that can cause breakdown across the surface of bus bar sections and the fixed portions. So higher risk of the bits we interact with, but obviously could occur anywhere within the switchgear. So it's just a flavour of what PD is, and you can kind of see some of the effects there. Broadly, there are kind of three main categories of PD, and depending where your switchgear is, you might care more or less about some of these. So internal discharge, that's happening inside the insulation. So that's very much like the CT on the last picture. These air voids, impurities, concentrating the stress and causing that breakdown, which then create a void within the insulation. Hard to see, hard to identify from the outside, and usually require a reasonable amount of intervention to address. Luckily, about 70 to 80% of the activity is more surface activity. So this is stuff that's occurring on the surface of the insulation. This might be on the bushing, etc., tracking down the outside, and is the carbonisation we saw visibly on the last picture. So the stress has got to build up for some reason on the outside of that, on that surface. That could be from a sharp point, an earth point that's local to it, or point of other potential, or it could be from impurities, humidity, high, etc. Once that's started, there's a weak point and it'll continue. Final category is corona discharge. So this is discharge to air. If anyone's walked under an overhead line on a wet day, you'd physically heard this, probably had to see it in extreme cases. And in certain situations, you'll hear a lot of people say, this doesn't matter. And that's true. If it's there in some of the outdoor yards, etc., you won't pay that much attention to it. And that's right. If that's in an enclosed environment, that has secondary issues. So if you're seeing corona discharge going on in the cable box or in a sealed environment, that will lead to byproducts being produced that will actually corrode the box itself and the metal work around, and so there'll be a secondary failure. The final state on there is basically to say, look, they're the ideal, they're the three main cases. There are subcategories of this, things more complicated in real life. You'll have loose bolts, stuff that will also create gap discharges and more combined activity where you are getting both TEV and, both surface and internal activity. That's the key types there. So moving towards the helpful side, really. So how can we actually detect this? This is going on. What is it that our instruments are looking for? How are we seeing this? So all the activity, bulk of the instruments we produce are designed to be used in the system live. So we're sitting on the outside of a box, outside of the switchgear, trying to identify this small spark that's going on. And you can think of this spark in very much the way you would for an igniter on a gas oven, a piezo type igniter. And it's a very fast, small release of energy. So that speed of that pulse is helpful because it gives us a broad range of energy in sort of radio frequency area, and we use a technique called TEV, which is transient earth voltage, which is basically looking for that fast pulse as it travels to ground across the surface of the switchgear. Obviously, being a spark, it does produce light, it does produce heat in such small amounts that they aren't sensible ways for us to look for it. But it also has a sound, and that the audio activity is really helpful to us. So where that's occurring inside the insulation, obviously that isn't an easy thing we're going to be able to access. We're not going to be able to see that pressure wave. But on the surface of the insulation, so as in the middle picture there, this is actually a really good way of picking up early activity, hearing that crackling and sparking. And the final side, there are gaseous byproducts produced that will eventually then cause the nitric acid and other things in the local area. The concentration of these can build up. If you walked into a substation, you smelt ozone. That is probably from PD activity, or certainly some sort of arcing. They can get to that level of concentration, but generally the moving air through these and the outdoor sites, etc. The other techniques are more preferable. So techniques in the so we use TEV right up to the UHF frequency, so the electromagnetic frequency or the audio range. That's roughly what PD is. So why do we care? So I've got a couple of case studies here. The first slide is activity that we've picked up. So these are just three very simple recent examples, to be honest. So the first example on the left-hand side there is a cable crutch. The coils have been crossed. There's high stress, and you can see just some white compounds starting to build up between two of the phases there. That white compound is part of discharge, and the graph below, it's a bit more detail for future presentation, but that's the output from the instrument showing that there's activity related with the 50 Hertz phase, and you're seeing there's a couple of humps in that, so there's two phases involved in the discharge. Helpfully, the devices these days simplify that interpretation. So there's also a box to the side there which is showing that the classifier from the device is saying yes, this is PD. So on site you're getting some really simple feedback. Moving across, this is surface activity again. I think this is the vacuum bottle to the base of that. And again, this is picked up with an audio sensor. So we use an ultrasonic sensor, 40 kilohertz centered, either with a direct air path or there are versions that can work through sealed boxes, etc. And the final one, there is a cable crutch, which was producing actually TEV activity on the earth, but also strong ultrasonic activity. Just demonstrating there that you haven't got to be close to this discharge to pick it up. There are accessories that allow you to do this from a number of meters away at the base of the pole and identify the location of the pole of the discharge. That particular one, I think, went to fail about 4 months after detection. So you can see the detection there and the movement to failure. So the good news is we as EA that designed the kit can use our own kit. I suppose the more important message is that so can you. We've really much designed this kit to make it easy to use. And I had a very quick look on LinkedIn when I was putting this together, and just a couple of our customers very helpfully tag interesting finds. And this is work that yourselves, people on the call, have achieved and put forward. So here you can see the screen of our device, a handheld device, showing that there's 25 dB of activity going on. There's a phase plot. You can see that green line at the bottom of the two bumps, showing okay, it's PD activity. And you can see then, as I've opened up the kit, you can see that verdigris on the surface and the slow breakdown of those bushings. The nice bit here is if you find this early enough, the replacement is easy. The service and cleaning up the surfaces, putting it back to addressing your clearances and put it back into service can be done relatively quickly. So there's a real benefit to the customer of doing these surveys, identifying kit early before that led to failure. As we've seen from the previous slides, it would eventually fail. Another example to me shows a step change in how the equipment's changed over the years. So this was a customer who could see ultrasonic activity from the full bus bar section of this particular piece of equipment. Traditionally, that might have been more warning side for noise. People would have initially looked at that and say, this is everywhere, there's some sort of background noise. But the classifiers built into the kit now say, no, this is actually PD, and the ability to listen to stuff live rather than just look at a number on the screen or initial light colour. Had the confidence to take the outage and show that actually every single boot on the bus bar in this instance has cracked. So there's a genuine issue there that once it's corrected, the levels dropped. So there's a couple of case studies. Our next webinar in December, at the end, we'll actually go through a number of case studies, how it was detected, what was found, what the follow-up action was, and really let you see what the closed loop of this could look like. So we're going to do a year review in December on that. And it should be interesting. Okay, so we know what it is, we know why we're doing it. Very high level, how do we test for it? Again, the nice bit here is it's dead simple. And it's no different to any other condition monitoring process, whether it's be looking after your car and servicing it. It's exactly the same mentality. So the 4 key steps really is understand what your failure modes are, what's likely to go wrong. You can take every measurement under the sun and completely miss important stuff, so focus around what is important, what's likely to fail. Then choose some techniques that can help you identify those metrics and give you reliable data. Collect that data, the right regularity, and then really importantly, do something about it. That last step can often be a challenge. So the first step then, what would cause issues on your HV equipment? So this is some data for 11 kV air insulated switchgear. It's from the ENA and NEDA's data. And that top graph on the right hand side there is saying, look, these are the causes of failure. And by far the biggest section on there that's leading to failures is the breakdown of insulation. So if you're going to choose one intervention, you choose to intervene in that area. So insulation breaking down is the bit we're going to look at. And luckily, that's where PD fits in. So how do we look at insulation? What techniques are available to us? And the challenge is there's a whole host. So the whole host of techniques are out there, from the handheld surveys, so the PD activity around that, which allows you to do a spot measurement around many different assets, so not just metal clad switchgear, cables, outdoor substations, GIS gear. We can use a handheld device across a whole range, and that gives you a spot measurement. So that's one starting point. You can do that with the gear live. On more critical assets, you can move towards monitoring, and you could have a permanent version of that. Or you could do things with thermography and look at high resistance joints, etc., for as a complementary service. All those 3 can be done live on the equipment. Some other techniques you could choose to use are more offline services. So the cable comes out of service, the switchgear comes out of service for these activities. And whether that be the cable mapping side of things, so this is where you apply a lower frequency sine wave to the cable. That allows you to again look for PD, for breakdown of the insulation, and give you a distance down the cable. Has the advantage doing it online, there's less noise typically. So you can get quite often taken as a follow-up service once you initially identify PD in a live situation. Before you go and joint the cable, you'd use that technique to locate it or build on the location we'd already given. can be there's fingerprinting type technologies. So like live is often used on longer cables. It allows you to sort of look at how the frequency response of the cable has changed over time. Again, identifying issues. There's full transformer test sets where you can energize or take the transformer offline and test installation of the transformer. And also in the complementary to this is very much around the vacuum interrupter testing. So vacuum bottles are really common on the network now. A lot of them are reaching their design life. And how do you know that vacuum is still good? And there's a couple of very simple techniques for taking them while they're in service, taking measurements on them and proving that the vacuum is still intact. So the technique we're focusing on today is very much on the PD side for the handheld devices. And our device in that area is the UltraTEV Plus 2 handheld device. So this is the latest in a long line of PD instruments. It's also a device that we've built as a platform. So we've released probably about 35 software updates to this since we first put it onto the market. And each of them supporting new accessories, new measurement techniques, new analysis techniques to make your life as the end user easier. So the device is very powerful in that way. It'll do a lot of analysis automatically on the device. It will tell you, for instance, ultrasonics, that yes, this is PD, this is noise. It'll also record lots of information in the background that allows experts and more central office support to back up your decisions rather than having to make every bit on site. So it is applicable everything from cables, metal clad switchgear, outdoor compounds, GIS installations. There is accessories across our full range now, covering UHF and wider. So quite a flexible device in that sense. So that's a technique we choose to move forward with. Okay, so we know why we're doing it. We know where we're what we're doing. We know what's likely to fail. We know what technique we're going to use. How do we collect that data now? So, should we do it once a week, once a month? How often should we be there? So I'm really unhelpfully not going to answer that question now. Because the answer is it depends. The good bit about PD is that it tends to trend. It tends to start small, as you saw, that small arc, and it will progress over time. So you generally get a warning period, and that warning period is normally substantial. But it isn't always. It depends exactly where it is in the levels of stress around that part of the insulation, what's caused it, especially if it's something that's moved and that's then caused that to kick off rather than a static portion. You tend to get slightly less time. So the key bit is it's got to fit with your risk profile. And what you're looking for is trying to manage that time between being able to detect it and failure and make sure that is reasonable. So in this particular example, a cable crutch, there's roughly annual measurements going on. I think COVID happened in the middle of that, by the looks of it. And then there's the first indication of activity is July 2022, when we got a medium level of PD. So it's gone from healthy to medium over that time. The nice bit is that the latest devices with all the recording, you can actually make quite a good judgment, because even when you got the green, typically you wouldn't have recorded anything, but now you'd see the exact levels. Was there any low level activity going on? It can inform your time to failure. But they had 7 months after this prior to the failure, so a reasonable length of time to react. So the full answer, I suppose, to how often is what's the risk. If this is your incoming board, sole supply to your factory, and more importantly, if it's going to cause you to have a very bad day if that goes offline, you might look every couple of months, every month even. If it's a completely redundant circuit, low risk, it might be every couple of years. That really does depend on your criteria. And we'll be giving some examples on that in a later webinar. And our Australia office actually did a really good, but has done a really good webinar and presentation on this previously. That's worth taking a look at. So that's how often. The next bit that's really key is where. So every switchgear has the generic sort of approach like we saw previously, where the moving parts, that side of things, are going to be a higher risk. But there's also a history to this gear. There's thousands of most of this design, of each design across the network units, and you aren't the first person to have operated that type of gear or to be maintaining it. So we need to lean on that knowledge bank. We know, for instance, that surface activity can be particularly bad in some cases. To other issues have been internal discharge, we've gone through the bushing support, etc. That information's out there, and certainly for ourselves, we've got a team here that can help advise you on that. And the key bit is making sure that for the gear that you have, you understand what the cross section looks like, you understand where items are located internally, and you can understand the history and the most likely causes of failure within there. We can then target your measurements as you go around, and that will really improve the quality of your services. So that's an area we can assist with. So a couple of examples I will say, by the way, these are just two examples of issues. These aren't particularly bad pieces of gear or anything else, so any of the manufacturers are on there, they're just examples. The final one, the most important one, is then to plan your actions. So generally you've got time to do this. You've got to feel if you've been doing regular measurements of how quickly something's changed, and the rate of change is certainly a good indication of time to failure. There's details go through in the future webinar and training of how the width of the activity is changing and the number of pulses in the cycle, etc. There's evidence there to show how quick things are likely to fail. So you do need to plan them. If you don't, I mean, this is the same site a few months apart where there's activity going on, nothing was planned, and you've now got a bit more of a clean-up operation, probably right across the bus bar in that case. The initial addressing this before it fails is so much simpler, it's cheaper, you've got less secondary effects to deal with, and also once you have had a failure in that, obviously you've got contaminants and everything else across the whole bus bar, across a wider switchgear, you're more likely to have failures in the future. So there are a lot of benefits to addressing this up front. So that's roughly what PD is, the process to detect it. I mentioned before that stuff's changed quite a lot over the last couple of years especially, and I've put this under the title of sort of maximising your impact. We've always gone to site, we've always took PD readings. You'll know your own policies, but most people record maybe a red, amber, green or a dB level, so an amplitude level. Probably about 70% of the industry is still at that sort of level of activity. The devices and the technology's moved on that can give you another step change in benefit from that. So traditionally, if you look back far enough, PD measurements were purely there from a safety case, and still valid from that way. If I was going to work alongside a piece of switchgear for the day, I would do a quick PD survey. It takes all the minutes and just gives me some confidence that the status that if I was going to switch, I'll certainly take measurements pre and post switching. That's purely from a safety point of view. What's changed is the ability to link that to a wider asset management sort of case. Now, that's always been an idea, but it's been challenged by actually how complicated this stuff has traditionally been to use. So if you look far enough, there's a lot of people turn up with oscilloscopes and devices like that on site, take the measurements. But trying to collect good data at the end was always challenging, and training staff to that level was a challenge. So that's limited the ability. And then having to make the decision on site, not being able to easily communicate that back. So during COVID myself, I had lots of phone calls where people were playing audio files down the phone to me, etc. To what do you think this is? And that really brought home the need to concentrate this centrally and be able to support people on this. So there has been a major shift in our devices, driven partly by that, to allow this end-to-end connection. And the journey from that's been remarkable, actually, probably more than I expected. We've trained hundreds of people on the use of this in the last 12 months alone, and really seen a change in how PD is being viewed and used in their business. So it's hard to take a spot measurement into a system which allows you to take a more holistic view of the condition and prioritise what, if you wish to go that far, what investment decisions you wish to take. All sounds very grand, but what does this really mean to you on site? So As I said a minute ago, the biggest challenge is people taking the right measurements and consistently taking those measurements. The biggest challenge to how long have I got and when our net gets got to react is the only time anyone records any information currently is when they get a red or an amber light or something's past a critical level. And them levels are already months into the activity probably. They're based upon statistical likelihood of failing in a short period. Being able to record data consistently and have the early view allows you to get that planning better. So what we've enabled to the device now, I'll just press play in this video where I talk, is you'll see on that screen, in fact, just pause out there a second. Oh, I regret pressing buttons, I apologise. So I'll pause out there for a second. You'll see the device now has got the capability of having a link to a central system, understanding your asset information, removing any data entry on site, so there's no typing, there's no errors in that data collection, and allowing the device to take you through what measurements to collect next. So in this instance, it's telling you which panel to go to, which accessory or which part of the switchgear, which accessory on the device to use, on what measurement you're going to take. You then, as you go through the measurements, you're literally hitting record on what can be the most basic of screens. And in the background, that's recording all the information required to do a full analysis. So allowing to push this a lot more to the end user, to the network edge, while giving people back at the central office, which is where your experts aren't having to go to site, the ability to analyse the data fully. So what does that look like? That device is wirelessly linked, a Wi-Fi connection, hotspot, etc. Back to the central system. This is a typical panel overview of your substation, so your panels and the measurements been taken. And there's interpretation on there to then say, okay, actually these ones we think are PD, and this is your first cut view of where you should be focusing your analysis, based upon the colour coding on there. The analysis has moved on a long way, so you now see your full detail centrally, your phase plots, your waveforms, etc. And there are things in there to filter out noise and allow you to clean up your plot to look at exactly what is the PD. We choose this on the central data because our device collects all the data up front, and that way you're not omitting any of the data unintentionally. So there are versions out there where these settings we set on capture. We have the full resolution data centrally, and then we can filter that as required. An example of the waveforms, etc. on there, you can do if this was a cable, you can do location down the cable and start to through TDR techniques, and you'll be able to tell how far down the cable the discharge was, the issue is. So all from this little handheld device that's connected and giving you full visibility of your network. There's a big step forward. The next big change is what we do with that data. So from the UK DNO background, but also wider in industry now, the methodologies, one of them's CANIME, which is a Common Network Asset Indices methodology, which is a way of taking this PD data, aligning it with some other types of data. So you might have some visual information for the switchgear, some duty cycle information, location, and starting to build a view based on your portfolio of where the risk is and what you should be responding to. So this is our Invest platform, and we will cover this in more detail in a later presentation. But that journey now is no longer a spot measurement. It can take you all the way through to a fully integrated solution. And just to add, the UltraTEV Plus 2 itself has got the ability on there to ask custom questions, collect wider data information on there through very structured question sets you can put on. And you can, again, link them back to the cloud and collect the wider asset information, which is certainly seen quite a strong uptake. So that's the Invest platform and kind of what's moved forward. So a quick overview of PD, where you need to measure, what you need to be thinking about, and really where you can be taking this right now, which has been quite exciting changes over the last couple of years. That's it for myself. So thank you very much for listening. I'll pass back to Hazel.
Thanks, Gareth. I hope you've all found that really interesting. I know I have. So I guess the next question is, how can we help? And I think Gareth touched on the services that we offer, but our main aim is to make your life simple. We can offer support all the way from providing you with instruments, or on-site services where our team come out and either support you to do the testing or do the testing on your behalf. So we can help you all along your asset management journey. We're independent, we're not associated with any manufacturers, and we really do pride ourselves in our ability to train people in how to use our instruments and use them well. We literally train hundreds of people every single year. We have got a couple of things to mention at the end, and this is purely because you may not know how to use the instrument, or you may not be aware of the instrument. So if you would like to book a demo, please get in touch. We are running an offer at the moment to have a free electrical network gap analysis as well from our current consultancy team. So there is a web page on there that you can put your details in, and we will be in touch, and we can come and demonstrate the instrument for you or help train your staff. We also do an awful lot in the education and supporting development space. We run the Industrial Power Engineers Forum twice a year. The next one is the 27th of November. So if you would like to join us for that, please do let us know. We'd love to see as many of you there as possible. And just to let you know what's going on going forward, Gareth and I have both mentioned that this is the first in a series of webinars. The next one we are planning for December and then on into the new year. So as soon as we've got that date, we will be letting you know, and we hope you'll join us again. And I can see a couple of questions in the chat, so I'll just start by going through those for the last 5 minutes. So the first question I've got is, what is the difference between testing a conductor on and off load? And that's from Andrew Williams, Nordex UK.
Okay, so loads, it's a common question on the PD side. So first of all, I think important is its voltage that's causing the stress across the insulation, and it's the voltage that will basically decide whether the PD is going to activate or not. So in one sense, load doesn't apply. The caveat to that is obviously as materials heat up and warm up, they change dimension. So it's not unheard of or uncommon, and there's certainly, I think, a good case study in London we looked at a while ago, where this particular site used to discharge about 4 hours after the day started. So the load came on by mid-morning, late morning, get this discharge on site, and it was drop off by 6, 7 in the evening. And that was to do with heating in the joint itself. So the load was causing the joint to heat, change dimension slightly, and then you got PD activity from there. So it's a voltage that causes the stress, but the load can change and the heating certainly can change the dynamics. And obviously vibration, other things as well from the load can have an impact.
Brilliant, thanks Gareth. Andrew, I hope that answered your question. The next question I've got is, can you test HV and LV cables? And that's from Colin at AWE. Okay,
so hopefully through the webinar you've seen we can test HV cables. You do that through use of HFCT normally. That will go around the earth strap of the cable and allows you to do PD detection and TDR, etc. for location down the cable. You can also do them offline. LV is slightly different. So LV, you will not get the insulation is normally to a level where you don't get PD activity at LV, but you still get cable faults. So the equipment I've talked about today isn't the right equipment for that. If you look at our other products on the website, so there's a product called the VisNet, which is a network visibility tool for LV. That will use something called pre-fault, which it's a similar concept. It's seeing the pre-arcing to failure, and that works on the LV cables. So that again uses impedance to fault to see that pre-fault activity. So yes, you can do it on LV. It's slightly different failure modes, not strictly PD, and but it'd be a different tool set to do so.
Thanks, Gareth. And I think it's the last question we're going to have time for, but this is from Hilton at PQ Flow Solutions. What accessories are included in the UltraTEV Plus kit, and what are their applications?
Okay, It's going to be a long answer. So the traditional accessories and the measurement techniques we use are transient earth voltage TEV, so that's a plate built into the top of the device, and ultrasonics. So ultrasonics built into the device, and there's also 2 or 3 accessories in that area. There's some accessories to help you just look at place it harder to reach. You can still see the screen over the top of switchgear, etc. We showed that example where we found termination on the pole. That's done from an ultra dish, so it's a parabolic dish that allows you to look at and concentrate that energy over a long distance. And there's also a device for looking inside sealed boxes where you haven't got an air path. That's the contact probe. So that's fairly traditional on the ultrasonic side. For the cables, we have the HFCT we've mentioned, so that'll go around the earth strap, up to split core CT for the earth side. And then you start getting some more interesting sort of newer releases, which I think probably where his question is. So we've added in a device which works on the VDS ports or the VPIS ports, the voltage presence indication sockets on switchgear. They helpfully have a capacitor that connects them to the cable termination typically. There's an accessory that plugs into that, and we can use that as our detection boot into the switchgear. So that's a VPIS accessory. There's UHF accessories, so looking for GIS switchgear. We have band joint sensors for using on, let's say, high voltage GIS. We also have outdoor UHF for outdoor compounds. So there's a directional antenna that will allow you to see activity within the insulation in outdoor compounds. Really helpfully, it ignores corona. So a lot of other techniques you see on the market, cameras, etc., give you a lovely view walking around the outdoor compounds, but there's a lot of corona picked up, and that's distracting from what's actually important. So that's got quite an important application, actually, that one, the directional antenna. There are further accessories, but they're kind of the headline ones, I think.
Brilliant, thanks, Gareth. As I mentioned, that is all we've got time for today. These are our contact details. If you do have any further questions, please feel free to drop either Gareth or myself an email or give us a call, and we can help you through any queries you've got. As I mentioned at the top of the webinar, any questions that we have had through but haven't had time to answer, we will come back to you with answers. And just for everyone to be aware of, we have made a recording of this webinar session, which will be shared with you all over the coming days. So to close off, thank you very much for attending. I hope you've enjoyed it and got something out of it. Please feel free to give us some feedback, and we'll see you on the next webinar.
Thank you all.
Thanks, everyone.